Next comes insertion sort, a slightly different sorting algorithm. It works by inserting items one by one into a sorted region of the array. For example, here is an array to be sorted. Insertion algorithm works by maintaining a sorted region at one end of the array, here in the front. Initially, the sorted region only contains the first element. Each time, we take the first element after the sorted region and insert it into the sorted region. After the insertion, the sorted region grows by one element but remains sorted. Our insertion starts from 2, the element at index 1. This is our array after inserting 2. You may have figured out that we need to shift 5 to insert 2 in front of it. Next, we insert 4. Obviously, 5 is shifted again, but 2 doesn't need to move. Now we insert 7, which just stays where it is. Now 1. All elements in the sorted region is shifted to make space for 1. Next, 3. Some shifting. Now 4. By the way, there are 2 4s in this array. We mark the second 4 so we can see how this algorithm handles multiple copies of a value. This 4 is inserted right after the first 4. We like this as it reserves the relative order of the 2 4s. Imagine the original order actually means something, such as the time the data is added into the array. When 2 items are equal, it makes sense to keep the copy added later after the first copy. Now we have one last element to insert, 6. Here is the array after inserting 6. Now the sorted region extends to the whole array. So our array is sorted. The insertion sort algorithm provides an alternative to the selection sort algorithm for sorting small number of items, such as 20 or less. It's more efficient than selection sort if the array is only slightly out of order. Let's break this into steps too. Can you first figure out the algorithm for insertion sort? Here's one snapshot of the example we just looked at. The answer is C. Insert element add I into the sorted region from index 0 to I minus 1. I starts from 1 till the last element. Recall what we did on the example. The sorted region starts with the element at index 0. There's no need to insert the item at 0. Our insertion starts from the element at index 1. We need to insert it into the sorted region. Next, insert the element at index 2 into the sorted region. Keep going. Finally, insert the last element, the one at index length minus 1.